Sure.
We are ready to go.
Hello everybody. Welcome to our dress rehearsal, if you would, of the 2023 National Chemistry Week program of the Cleveland section of the ACS. Now that was a mouthful. Before we get started, I'd like to introduce the members of our planning committee, starting with Helen Mayer. Say hello, Helen.
Hello.
Come on over, Eve.
Dramatic.
Our newest member, Eve Genevieve, I guess I should say, Crane from the Cleveland Clinic. Xiaowei Yang from CSU.
Hello.
And Bob?
Williams.
Bob Williams, of course, from wherever, retired, right, Bob?
Right.
Okay, several of us are retired.
Formerly of Dubersall.
Formerly of Louisville. Okay. I'd like to start off the program by reminding you that there are several forms in your kit that we would like you to be aware of. The first one, I know you can't see them very well, but the first one is a photo consent form. The libraries usually have those, and so if they get the kids, or the parents, I should say, to sign up for the photo consent form, you don't necessarily need to use ours. We also have two very important forms, a student feedback form and a demonstrator form, feedback form for you as well. If you would please fill this one out yourself, of course, and at the end of the program, while they're still remembering what they saw, ask the kids to fill this student feedback form out. We'd appreciate it. Okay, let's get to the program. We have 6 experiments this year, and the title of our program, the theme that we always get from National in Washington, this year it's the healing power of chemistry. We have 6 experiments, and I got a cheat sheet here that I'm going to refer to from time to time. 6 experiments, you can read them of course, but let me just go through them real quick. They are all group experiments. We found that that was the best format for all of them except for one, the second one. The first one is no more sunburns. Second one is why wash our hands. That's the one, that's the individual experiment that all the kids will do. How do gallstones form? Bile aids digestion. Cell membranes are flexible. And how cell membranes are stabilized. Dr. Crane's going to tell us all about that. Okay, I'd like to remind you too of a couple of things that are in the script, but that you need to be aware of and make sure that you look at. First of all, I really recommend that you contact the children's librarian at the branch where you're going to be presenting. Introduce yourself before the fact. Make sure they're aware that we're looking for 25 students max, and that you will be there an hour in advance to set things up, at least an hour in advance. Also ask them if there is a person on their staff, maybe a page or maybe the librarian herself, who would be willing to help you both in the setup and in the performance of the program. There's a blue plastic tray in each one of the kits, and you can use that to set items up on a main place somewhere using that tray, and then have someone help you distribute those as you go through the experiments. There are some at-home functions to perform on page 5. Recommend you do those the night before. There are materials that you need to bring. They're on page 7. You're going to be in a hurting way if you don't bring those materials, so have a look at that. Okay, let's get into the story just a little bit. In the script on page 13, it talks about introduction for the students, and it suggests, or says you might consider reading the storyline to the kids. And I think that wouldn't be a bad idea. Well, here we go. Here's the storyline for this year. Remember that Billy and Avogadro are the ACS children's characters that you can find online. Millie and Avogadro are on a mission. There's been a rash of medical problems in their families lately, Avogadro received a painful sunburn while on a hike with Millie, and his mom got a serious infection resulting from a cut on one of her hands. Millie's grandfather has developed something called a gallstone. Kids aren't going to know about gallstones, but Grandpa does, which is causing him pain and discomfort, especially when he eats his favorite food, fried chicken. So Millie and Avogadro decided to consult with their friend, Dr. Genevieve Crane at the Cleveland Clinic, to find out what was causing these problems and how to deal with them. Dr. Crane is a specialist called a pathologist. She might even mention what a pathologist is. It says here, a type of doctor who interprets laboratory tests and with whom other doctors consult to help figure out what's making their patients sick and the best way to help them. Millie and Avogadro learned from Dr. Crane that chemistry has a big role in keeping their bodies functioning normally and in healing their bodies. She gave them tips about using good nutrition and chemistry to help keep their bodies free from these sorts of problems and how some of the body's chemistry works. Dr. Crane went on to explain that all living beings are made up of cells like the one shown, and there is a packet of diagrams. This is the one, this is the first one. This is the model of a human cell, and I would point out that we're going to talk about membranes. I'll get to that in a second. It talks about the cell membrane right down here on the bottom left, okay? So show the kids this model of a cell membrane. They don't need to get into the details of what the cell is all about, but they need to understand that there is something called a membrane that surrounds the cell. And we'll be talking more about that membrane as time goes on. Some living beings, like bacteria, are made up of only one cell, and others have many cells. The average adult human body has around 37.2 trillion cells. Each cell is surrounded by a membrane, which in some ways, as we'll see, is similar to a bubble, a soap bubble. The membrane regulates what nutrients the cell takes in and out, and helps it communicate with the environment. As part of the body's defense, its immune system, some cells can interact with and eat, kids will love that, they love all this wow stuff, eat microorganisms such as bacteria to help keep the body safe. These cells are called macrophages, and that's the last time I'll use that big word. We'll learn today about how chemistry affects and heals our bodies as we go through the program. Okay, I am going to deviate now from the text a little bit and just go into a kind of summary that I put together. If you look at what's going on in the script, if you read it beforehand, you'll notice there's a couple of twin themes that are running through the program. We get into surfactants, and I think you probably might want to mention to the kids that surfactants, of course, the word is a shorthand for surface active agents, and explain to them how surfactants work. Helen's going to talk a little bit about that when she gets into her experiment in a minute. The surfactants that we're going to be talking about today are soap, bile, and phospholipids. Say that one fast, 5 times. And membranes. Those two themes, twin themes, surfactants and membranes, run throughout the program. Experiment 1 introduces the concept of chemicals protecting the body. That's about sunburns. We introduce surfactants in experiment 2 and tell how they work. Experiment 3 introduces bile and mentions that it's a surfactant as well. Experiment 4 demonstrates how bile breaks down fats by substituting soap in our experiment for bile to break down fats in the milk, causing it and food colors to swirl. That one, I think, will have a high wow factor for the kids. Ooh, look at the pretty colors. Experiment 5 simulates the concept of membranes using soap bubbles, which act as inside-out membranes. Dr. Crane will explain that. How membranes are composed of surfactants called phospholipids, and how they're flexible and self-repairing. When we get to that point with experiment 5, Eve's got some wonderful little models of phospholipids, that she will use to demonstrate to the kids what's going on. And experiment 6 simulates membrane stabilization by adding reagents to soap bubbles to stabilize them. So a bunch of really interesting and fun things for the kids. Real high wow factor, something we always try to concentrate on. Okay, with that, I'd like to get started with the first of our experiments, number 1, and Dr. Mayer, if you would please.
All right, the first experiment is called No More Sunburn, and what we're going to do is to demonstrate to the kids that suntan lotion actually works. So you can start by asking the kids, when they go out in the sun, what do they do to protect themselves? And hopefully suntan lotion is one of the things that they're going to talk about. So when you are setting up this experiment, you're going to have 3 cups. You will notice that one of my cups is different than the other 2 because my kit only had 2 cups in it. Hopefully your kit will have 3. What you'll do is you'll put some beads into each one of these cups. You'll ask the kids to find the cups and then 2 vials, one marked S1 and one marked S2. So we're going to take the vial that's marked S1 and one of our little transparency sheets, and you're going to ask one of the kids on the table, this is going to be done 1 per table, you're going to ask one of them to go ahead and spread the suntan lotion on one of these. At the same time, ask another child to spread the other suntan lotion so that you don't waste any time like we're going to do with me. If I had thought about it, I would have finished one off beforehand. You know, just like Julia Child, you know, she pulls something out of the oven, you know that she put it in the oven a long time ago. So we'll put that one on top of here, and then we will take the other one and the other Q-tip and spread it over here. Some of the kids may need some help with the spreading, and if there are adults in the room, that might be something that they may. The older children should be able to spread it easily. The younger children may have a little bit of issue with it. Okay. And we'll just place that on top here. Then you, as the demonstrator, you will have one of these UV lights. And what we have here are, we have beads that are UV activated. So if you go outside during the day, with the bright sun, they will change color, and we're going to use a UV lamp in order to simulate sunlight. So you will have to go to as the demonstrator, this is where you're going to need a really long extension cord. So you will go to each one of the tables, and you will see that the one without any suntan lotion changes colors pretty quickly. Let's see what happens to the others. So they're definitely lighter. And if you look at them, one of them should be much lighter than the other one, but in this particular case, it looks like they ended up being about the same color.
Go ahead.
All right, experiment number 2 is why do we wash our hands? And a lot of kids think that all they have to do is take their hands, run it under the water, and voila, it's washed. After all, you don't see any dirt on your hands. But not only does washing with soap get rid of the dirt, it also gets rid of the germs. And what we're going to do is we're going to simulate what happens with soap by using pepper. So everybody should have a small saucer with a little bit of water, and we will have poured a little bit of water into it. Each child is going to do this experiment themselves. So we're going to take the pepper packet, and we are just going to sprinkle the pepper, all of the pepper, into the bowl. And you should mix it up. There. A little bit of clumping, but we're going to pretend that's the dirt that is our, those are our germs. So each child should pick up a cotton swab and take it and just put it into the water, and they should see that really nothing happened. So that's just like if I am washing my hands with just water. Then there's a container with dishwashing liquid called, I think it says 2P. And there's only 1 per table, so the students are going to have to share this. They'll each get their own swab, but they'll have to share the container. We'll just put just dip it into the detergent, put it in, check it out. Look at all of our pepper particles. They all go away. So it's the same concept of when you use soap to wash your hands. The soap will pull the germs away. So, so basically what's happening here, so you'll notice that when you put the pepper in the water, most of it stays on the surface. If it would sink, we would say that the pepper was more dense than water. Something that sinks is more dense, something that floats is less dense. But it turns out the density of pepper is a little bit higher than the density of water. So why doesn't pepper sink? Well, the pepper doesn't sink because this is where we have something called surface tension coming into play. Surface tension is like a thick skin on the water. It's caused by the tendency of water molecules to stick together. Water has a high surface tension, which means the water molecules like to hold on to each other and not let other things through easily. So that's why water bugs can walk on water, even though water bugs are definitely heavier than water. So because the water holds so tightly to itself, the pepper's on the water, but notice that when you touch the soap with the water, the pepper went scurrying off. That's because the soap is breaking the surface tension, and the pepper stays with the water near the edge. So in the case of germs, the soap will help the water wash the germs away. One other note, did you notice how fast the peppers moved? It turns out molecules can move incredibly fast in water. They move at a speed of approximately 1,300 miles per hour, or twice as fast as a jet plane. So that's really, really fast.
Experiment 3 is a simulation to simulate the formation of gallstones and or kidney stones. And again, in that case, you have material which is solubilized, and then it becomes insoluble, and you end up with something like this. And if it happens to be in your gallbladder, you're in trouble. So what we have is a supersaturated solution. This is a solution of sodium acetate. You have it in your kit. When you get your kit, you need to take the lid off, and you have mason jars instead of an Erlenmeyer. You need to take the lid off, put the piece of cardboard on, and heat it in a microwave. Typically, 2 minutes of full power will be adequate. We do not want the solution to boil. You want to bring it up to about 70 degrees C, which is just barely cool. You can usually handle it with your hands, but it isn't a bad idea to have hot baths or whatever. So,
Bob, do they take the plastic off?
yes, they do. They take the plastic off first, and then they put it in the microwave, and they heat them, and they will have either 5 or 6 jars. Most of them have 6, one for the demonstrator and one for each table. One only has 5. So cover it, put it in the microwave, heat it. This should be done before the session starts, because you want to allow this solution to cool back down to room temperature or to near room temperature. So you've heated it up to about 70 degrees, and indeed, if you come in, you would see we have a clear solution here. Everything is in there, but it is a supersaturated solution. And I'm going to add just a few seed crystals, not very many, just a few seed crystals. But watch what happens when we add these few seed crystals. As the video shows, all of a sudden it is crystallized significantly. It's now an opaque solution with those white crystals. It was a supersaturated solution, and we did something, adding a seed crystal to allow it to come out. And it doesn't take more than a couple crystals to start the process. And in fact, once you're back down to room temperature, you may want to be careful not to jostle it too much, or you might have it precipitate out more sooner than you're prepared to have them do so. So that is the gist of that experiment. Again, in our bodies, we have materials that are in solution, or at least are solubilized, and for whatever reason, they drop out. And when they do, they can form rocks. Those rocks can be in our gallbladder, they can be, or they can be in your kidneys, and both, I am told that either of them can be very painful.
I'm living proof.
I am.
Thank you, Dr. Williams, for a interesting experiment involving supersaturated solutions and gallstones. Next, we're going to talk about the function of bile a little bit. I don't know how much you want to go into using the word bile for the kids, but bile is formed in the liver and stored in the gallbladder, I'm told. And the function of bile is to emulsify fats so that they can actually be used as nutrients by the body. What we're going to do is we're going to simulate the action of bile using milk, and we're going to use a different surfactant called soap rather than bile. And I'm going to start out by cheating. In your kit, we have powdered milk. I think it works very well with powdered milk, but I happen to have some whole milk here. So we're going to try this experiment with whole milk and see what the effect of soap is on whole milk as the soap tries to break down fats. I'm going to put a drop or two of 4 different colors at 90 degrees approximately from each other. Okay, that's plenty of green. I think there's a food coloring kit for each table because this again is a group experiment. A couple of reds and a little bit of blue. Now, we fiddled with this experiment quite a bit, and we found that the way it works the best is with a small piece of cotton and a little bit of soap. And if I don't get enough soap this way, which I'm not getting enough soap that way, I'm just going to pour some on here so that we have a little glob of soap, maybe 1/4 inch in diameter. Then I'm going to turn this over so that the soap acts on the milk and put it right in the middle of those drops. Instantly you see interesting things start to happen. The colors swirl, and it's the same kind of action that bile is having in your intestinal tract as it does its thing to break down fats. Now, I think what we'll do is we'll let this cook, if you would, for a little bit, and we'll move on to the other 2 experiments, and then come back to this one later on to see how the colors have done their thing.